All right. Now we're going to discuss mole stoichiometry using things other than moles. And I have this analogy. It's on the back of your mole map. We've already talked about the mole ratio, and the mole ratio comes from the coefficients. So we take the known number of moles, we multiply by the ratio of unknown over known, and we get the unknown number of moles. However, we aren't always going to have moles to use. Most of the time, you're going to be given grams or some other measurement. And the moles are very picky about who crosses their bridge. You have to be a mole to cross the bridge. If you're not a mole, you can't cross the bridge. So you'll have to swim across. So you've got to figure out, based on what information you have in the equation, how do you change it to moles? It's got to convert to moles. For instance, if we start with grams, if we look at question number 1 on mass, and you'll notice it's the same, everything is the same, but instead of being moles, we're now in grams. We're starting in grams. Well, you can't cross the bridge if you're in grams. You're not a mole. You have to change to moles. So if we think about our mole map, how do I change from grams to moles? Well, I divide by the molar mass. So that's what we're going to have to do. All right. So on the back of your mole map, or your mole map, where the bridge is, write grams down on below the bridge and draw an arrow from grams up to known moles. And we just looked at the mole map. The mole map says that you divide by molar mass. So along this arrow, I'm going to write divide by molar mass, just grams per mole. And we get the molar mass either from using a molar mass calculator or our periodic table. So we're going to change from grams to moles. Now, in this assignment, it's asking us to find grams of oxygen. So once we get over the bridge, we're going to need to change back to grams. So we have to get off the bridge because grams are not allowed on the bridge, and we have to change back. In order to go from moles to grams, we multiply by molar mass. Okay? So that's the process. Now this is a 3-step process. You change to moles, known moles to unknown moles, and then moles back to grams. So let's try it. Our known amount is 12 grams this time of potassium chlorate. We're solving for grams of oxygen. So we're going to start out with 12 grams of KClO3, potassium chlorate. We have to get on the bridge, so we have to change to moles. To change grams to moles, and I'm going to use the rail fence here, but again, if the rail fence bothers you, you are welcome to just write divided by 12 grams divided by the molar mass. And the molar mass of potassium chlorate is 122.55 grams in 1 mole. All right? So, we do that math. Okay, so 12 grams divided by the molar mass, which is 122.55, is 0.0979 moles. Now the second step is to cross the bridge. To cross the bridge, we need to know our unknown, 3 moles of KClO2 divided by our known 2 moles of KClO3. When we do that, we get 0.147 moles of oxygen, and then we multiply by the molar mass. So now we're across the bridge, we're getting off the bridge, multiply by 32 grams in 1 mole, and we get 4.700 grams if I've done my math right. And you guys, of course, will tell me if I didn't do the math right once we get to class. Very cold here today. All right, next one. We start out with what we know. Our known quantity is 2.5 grams. We're solving for grams of potassium chlorate. So we start with 2.50 grams of potassium, divide by the molar mass of potassium, 39.098 grams in 1 mole, and that gives us 0.06394 moles of potassium. Okay, we're on the bridge. Now we need to cross the bridge. To cross the bridge, we need to know our mole ratio of potassium to potassium chloride. So that's 2 to 2. 2 moles of potassium underneath 2 moles of potassium chloride. So that would be the same number of moles of potassium chloride. Now we need to get off the bridge. So to get off the bridge, we have to multiply by the molar mass of KCl, which is 74.55 grams in 1 mole. And when we do that math, we get 4.77 grams. Okay? The next one, what we know is 1.2 grams of sodium oxide. What we're solving for is grams of sodium hydroxide. So, we're going to start with 1.20 grams of Na2O. We divide by the molar mass, which is 61.98 grams in 1 mole. And that gives us 0.01936 moles of Na2O. The next step is to multiply by the ratio. Na2O is 1, sodium hydroxide is 2, so we have 1 mole of Na2O to every 2 moles of sodium hydroxide formed. That should be 0.03872 moles of NaOH. Now we're going to multiply that by the molar mass. The molar mass of sodium hydroxide is 40 grams in 1 mole, and that comes out to 1.55 grams of sodium hydroxide that will be produced. Okay. Next one, what we know is 16 grams of sulfur. What we're solving for is grams of iron. So we're going to start with 16 grams of sulfur. Notice sulfur is a molecule of 8 sulfurs. So we can't just divide by 32. We have to divide by the molar mass of S8, which is 256.52 grams in 1 mole, assuming I did that correctly. And when we do that, we get 0.0624 moles of sulfur. Now we're on the bridge. The next step is to multiply by the ratio. The ratio of sulfur to iron is 1 mole of sulfur to 8 moles of iron. And that gives us 0.49899. I wasn't quite sure where to round, so I kept going. Now we're across the bridge, and we're in our unknown moles of iron. Finally, we have to get off the bridge. The molar mass of iron is 55.85 grams in 1 mole. So we're left with 27.9 grams of iron. Number 5, our known amount is 12 grams of sodium chlorate. Our unknown amount is grams of oxygen. Starting with 12 grams of sodium chlorate. The molar mass of sodium chlorate is 106.44. When we do that math, we get 0.11274 moles of NaClO3. My mole ratio, 2 to 3, so 2 moles of sodium chlorate to 3 moles of oxygen. That answer is 0.1691 moles of oxygen. So we're over the bridge. Now we have to get off the bridge. The molar mass of oxygen is 32 grams per mole. How do I know that? Oxygen is 16. 2 times 16 is 32. And that gives me 5.41 grams of oxygen that will be formed. Number 6, we have our known amount, 3.5 grams of silver nitrate. Our unknown is copper grams, 3.50 grams of silver nitrate. The molar mass of silver nitrate is 169.87 grams in 1 mole. So 3.5 grams of silver nitrate is equivalent to 0.20604 moles of silver nitrate. Next step is the mole ratio. 2 silver nitrates will react with 1 copper. 2 moles AgNO3, 1 mole of Cu. That gives us 0.010302 moles of copper. The molar mass of copper is 65.33 grams in 1 mole, and that comes out to 0.655 grams. All right. Really cold, people, really cold. 25 grams of iron 3 oxide is our known amount, and moles of iron is our unknown amount. So we start with 25 grams Fe2O3. Molar mass of Fe2O3 is 159.69 grams in 1 mole. That comes out to 0.1566 moles of Fe2O3, or iron 3 oxide. So now we're on the bridge. Next we multiply by the ratio. We're going from iron oxide to iron metal. So we have 1 mole of Fe2O3 that reacts for every 2 moles of Fe that is formed. That gives me 0.3131 moles of iron. And finally, I'm going to multiply by the molar mass of iron, 55.85 grams in 1 mole. And I get 17.5 grams of iron. All right, questions? I guess you can't ask them because I'm on a video. But you can ask them in class on Friday.